19, aplenty. The elves of Gear Island are thankful for your help and send you on your way. They even have a hang glider that someone stole from Desert Island. Since you're already going that direction, it would help them a lot if you would use it to get down there and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they've already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts, and they have a system. To start, each part is rated in each of 4 categories: extremely cool, musical, aerodynamic, and shiny. Xmas. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule specifies a condition and where to send the part if the condition is true. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Consider the workflow. EX, X is greater than 10, 1, 2. Alright, this workflow is named EX and contains 4 rules. If workflow EX were considering a specific part, it would perform the following steps in order. Rule: X is greater than 10. If the part's X is more than 10, send that part to the workflow named 1. Okay, interesting. Is this a recursive workflow? So we have a workflow of EX and we send, if we match this rule, it goes to workflow 1. Okay. Rule: M is less than 20. And A is greater than 30, then R. Otherwise, if the part A is more than 30, the part is immediately rejected, which is R. Rule A: otherwise, because no other rules matched, the part is immediately accepted. Hold on. Okay, so this is A is greater than 30 is the rejection, and the default is acceptance. Got it. If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. If a part is accepted, sent to A, or rejected, sent to R, the part immediately stops and any further processing. The workflows are listed first, followed by a blank line, then the rating of the part the elves would like you to sort. All parts begin in the workflow named in. This example, the 5 listed parts go through the following workflows. Ultimately, 3 parts are accepted. Adding up the X, M, A, and S rating for each of the accepted parts gives, for the parts with adding all of the ratings for all the accepted parts gives a sum total of. Sort through all the parts you've been given. What do you get if you add together all of the rating numbers for all the parts that ultimately get accepted? All right, what's our puzzle input look like? Gotcha. Okay, so we've got 2 blocks. The first block is the workflow rules, and then the final block is the answer. Oh, this is interesting. I mean, I'm kind of taking a peek here, but it's, if you get to GZQ, it's always accepted. So I feel like there's might be a micro optimization there, but is it worth it? I'm not really sure. So this doesn't seem terrible to me, conceivably, to just apply the workflow. We can take the values, parse them apart. We've got 4 values, and then we can then parse out the condition, which are just greater than, less than, it looks like. I think that's probably somewhat true. Let's see. Is there anything that says, I don't see anything that says there's only greater than and less than. We know we've got some workflows we got to process, and it looks like we only have greater than or less than symbols, so we can handle that. So how do we want to structure this? I think what makes sense to me is we break this apart by comma, and we automatically get a stack of destiny, essentially rules, right? And each rule consists of, I don't see any like combo rules themselves, but consist of a letter, a operator, and a value, and a destination. So letter, operator, value, destination. And we'll just create those. Each workflow has a stack of those rules. And if the letter is empty, then we assume that when we get to that workflow, it's just assumed. So in this case, RFG is just assumed because it's in the workflow. Same thing with accepted. If we get to that in the stack, then that's where we move to. And then we have a set of, what we call this? These are parts, right? They're the ratings for the parts, but we'll just call it parts. The workflow are listed, followed by a blank line in the rating of the parts elements. All parts begin in the workflow named in. Okay, so there's a workflow named in. In this example, the 5 listed parts go through the following workflows. So where's the workflow in? Okay, the workflow is here. Gotcha. Okay, so that's like kind of a special workflow. We're going to need a map anyway, so we'll start with that. We'll store these. So I think it's just my fear is that well, I don't. I'm my mind just being part of admin or doing admin code for as long as I have. I'm thinking about all the ways they might try to augment this problem to make it more challenging. And my fear is starting out in a specific direction too early and then finding out that it was a terrible direction when I get to part 2. But we're going to do it. I don't really see a better way. So not that there's a bad way with my approach, just it seems too obvious. Right. Cool. All right. So first things first, we got to break this apart into 2 pieces. That's pretty straightforward. Not a grid problem. That's okay. So strings.split s, and we'll do the double hard return. Just call it sets sub 0 and then sets sub 1 workflows wf and then p parts. So let's do the first thing, which we'll create some additional functions here. Parse workflows, and I'm going to create a type called workflow, which will be a struct, and I'm going to have a type. We'll just call it rule. Yeah, why not? Which we can also have as a struct, and a workflow is simply just a set of rules for right now. What we'll do here is for the rule, I mentioned operator, I mentioned the letter or the identifier. We'll just go with a string for the operator, and then let's see here. Destination. Do we need anything else? There's just a slice and identifier, the operator, and the destination. Yeah, I think that's fine. And if the identifier that we're comparing against, oh no, the value, which is int. Okay, so yeah. So parse workflows, we get in a string. And we return back a set of workflow. Let's do a map of string to workflow. I think that's going to work better because then we can do our lookups. So then we need to parse this individually. So for each line in strings.split, in this case, input is S and hard return and range over that. Right. So now on each line, let's grab a workflow. So we know that the operator is always going to be one letter. So we're gonna split this on the opening squiggly. This will just be a quick way. This will just be a quick way for us to kind of split that apart. And so our name, call it NAI. Our name is NAI sub 0. So that's that first part. And then our instructions are going to be NAI sub 1. Right. So at the end of this, we're going to set, let's create our workflows. And then our workflows right. So we know if we have a name and some sort of instructions that we're going to create a workflow. Right, awesome. We want to split we should call this what it is up there. Rules are raw rules. So we want one less character so we don't have the right bracket. And we want to split that on the comma. Okay, so then this goes away. I think this will be fine. Right, so for each rule, so now we've segmented it down to just this. This formatting got wonky at some point. Right, so let's create a rule. So now we're looking at this context here. So I think first we want to split on we'll split on rules on the semicolon. And what we'll say is that if length of items equal 1, okay, then we only have like this situation here, which is if all the rules don't pass. So that will be somewhat of a special case. we won't do anything complicated. We're just going to set the destination to items sub 0 because that's all we have. We have, in this case, we would have the PV. All right. So then the other case is we've got destination, which would be items sub 1. Now we've got this to handle. We've got to we're splitting it on actually we're not going to split it on a value because we can take the identifier will be items sub 0 length of 1. The operator will be one of index 1 length of 1, and the value will be index 2 to the end, and we're going to right. Okay, great. So now if we look at this rule that we're adding, we've got destination. That's one of what the 4 items that we have here for rule. Identifier is identifier. Operator is operator, and value is value. Perfect. All right, so now we've got our rules and our alleged workflows. And then we just want to return workflows. Okay. You know, the more I think about, we'll go ahead and we'll add the name here. It may come in handy later. The one thing I was thinking about is really a workflow is just a map of string to rule, or rules, like a slice of rules. Like we could get rid of this entirely, but I think this is fine. Let's do this. Workflows equal to parse workflows set sub 0. And so let's okay, I don't have the identifier. Okay, so I'm missing the operator for whatever reason here. Item sub 0. So we split on this. So I should have, and I've got the value. So what am I doing wrong? Am I messing this up again? Does this need to be the index plus the length that you're going to? Is that right? Yeah, okay, we got the operator now. So if I look at PV in our test input, we've got A17, A is greater than 1716. Okay, that looks good to me. We could write a test for that, right? But I'm not going to. All right, so we've got the workflows being parsed. Let's look at the parts. So and let's look at a part. Right. Well, if I did that, that would just be really annoying because then I have to map all the equalities. So I'm not going to do that. I'm just going to return the parts as a map of string to int. That way we can just, our string will be the XMAS, and then the int will be the value on the equal side. For line range string dot split s n and then it's going to be for rating in range of what are we splitting on? We're splitting on comma. And we'll do, it's really the parts rating, I guess, but who's counting? X equals 787. So this becomes slice of map of string event because we are going to have multiple parts. So slice of map of string event, and which would be a part. So right. So now we are going to we need to split so this one is going to be part sub I equal convert dot a to I and we're going to panic if ER not equal to nil. Ugh, I'm kind of disgusted with this parsing. There's better ways to do this. Okay, better ways, but this is reasonable for now. So we'll run this. Let's see here if we've got our, yeah, so now we got to do parts equal parts append, append parts part. Okay. Mutamus. All right. So now that we've got that, now we just need to process these. So I don't know why I did it this way. We're gonna delete that. We're gonna range through all of our parts, and we're gonna start on our workflow in. What are we adding up? Adding up the Xmas for each of the accepted parts, giving this part with. Okay, so we can do a couple different things. We can just score the accepted parts, or we can put them in a bucket and then do a sum at the very end, which I think is fine because that should be easy enough to score. So we'll create an accepted bucket, which is just a slice of map of string to int. And perhaps I could ID them, but right. So we've got our initial workflow, and I'm going to make an assumption that everything's going to end in either an accept or a reject. For rule in rules, I'm going to do something here that I think makes sense to me. Actually, no. I could create a method on rule that we pass in maybe the part or the values to, but actually I decided not to. We'll just do it in line here. So what we're going to do is we're going to say if rule dot identifier operator equal to that, let me just create a function called funcValidate. We'll call it isMatch. I think it's going to be easier to think about if we put it into a function, because then we can just return if that rule is true, and then we could add some things in here, right? So we can say if rule dot identifier equal empty, return true. Okay, so what's a rule? So a rule is just that, a rule. So we'll pass in our rule, we'll say R, and we're going to return a bool, and our default is false, and we're going to pass in a part, which is a map of string to int. So a P, which is a map of string to int. Right. Okay. So instead of this, we'll say if isMatch then we do something. And we'll pass in rule and part. Awesome. So if we don't have an identifier, that's the base case where if we go to our test input, it's the base case here where we don't have any other pieces of information. So we're just gonna, that's just gonna be our true state. We're gonna say, okay, this is the one that gets passed back. If rule.identifier equal to R, then we're rejected. And so we need to break, because we figured out the end state for this one. So we're going to break workflow. So we don't need to process any more workflows as rejected. We could put them into a rejected bucket, but we're not going to. If rule.identifier, or sorry, this is an identifier, this is destination. Rule.destination equal to accept. Also break workflow. And we're going to append, let's see, accepted equals to append accepted. And we're going to append rule. No, we're going to append parts. So now we'll have a list of our parts that are accepted. Is this an index? It's a slice. Let me do this instead. Let me return the indexes of the accepted parts. I think that will that'll be less data for us to store. And this will just be a slice event. And this will be I. So that'll be like the part ID. And that will make that a little bit simpler. And so if we don't have those two conditions, we don't need to break the workflow. We just need to assign a new workflow and break out of the rules loop. So W becomes workflows sub rule.destination, and then we break, which will break out of this for loop here. So this is a nice feature of Go with label breaking, where we can break out of a for loop and break out of our workflow for loop and iterate to the next part. And so now all we really need to do to score, and I can create a function called score. It returns an int, and it's going to take in our slice of map string to int, and it's going to take in our accepted, which is a slice of int, which is the index of this, and we'll call parts, and it's going to return that. And so what we're going to do is we're going to say for range of accepted, and we're going to say for val in range of parts sub I. So that's our key val relationship. And so our score is going to start at 0. And if I understood correctly, we're just incrementing and then we're returning score. And so this should become score parts accepted. We need to finish this. Okay, I got on a tear there. So what makes it accepted? So if the identifier is this, we return true. Otherwise, return our operator is a greater than sign. We are going to check to see if p sub r dot identifier is greater than r dot value. I think that's true. Otherwise, it's less than. Nice. All right, test passed. First try. Let's go. A little surprise, but we're going to run with it. Let's check out our actual test input, our puzzle input. And let's run. Is this day 19? I don't even know. I must not have added it here. Awesome. Great job. Man, that's exciting. First try. Got the answer right. I mean, we had the tests to help, so we went through a lot of TD, but it just feels good when first attempt. All right, part 2. I would say I do a lot of workflow stuff at work, so that these kind of things come easy. So even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe you can figure out in advance what combinations of ratings will be accepted or rejected. Each of the 4 ratings can have an integer value ranging from a minimum of 1 to a maximum of 4,000. Of all possible distinct combinations of ratings, your job is to figure out which ones will be accepted. In the above example, there are, considering only your list of workflows, the list of parts ratings that the elves want you to sort is no longer relevant. How many distinct combinations of ratings will be accepted by the elves workflow? Okay. This is similar in some ways to the problem that we approached on where we had min and maxes. What day was that? I actually got stuck on it for a little bit. I want to say it was it day 7, day 8? I don't think it was day 8. Day 9? Maybe it was day 6. One of these days, it was very similar in the sense that we ran into a problem because of... No, it wasn't day 6. Well, I'm not going to sit here and search for it if I can recall. One of the days was similar where if you just approached this in a brute force manner of all the possible combinations, that we wouldn't be able to solve it. So what we're going to have to do, I think, is each of the 4 ratings, Xmas, can have an integer value ranging from a minimum of 1 to a maximum of 4,000. Of all possible distinct combinations ratings, your job is to figure out which one will be accepted. What we're going to have to do is we're going to have to look at these rules. Let's use the simple example. Instead of giving this input, really we have to start with, could we do this with ranges? I jumped to that conclusion because I know we ran into a similar problem with ranges of numbers for calculations. I think we could take a similar approach where, so we're at in, and in has 2 possibilities. It has S is less than 1,351, which will go to PX, and QQZ. So in my mind, that means that we will pass one instance to PX that has the range from 1 to 4,000 for X, M, and A, but S would be 1350, 1 to 1350. And then we pass another instance to QQZ where it's, again, X, M, and A, but over 1351. So 1351 plus 1351 to 4,000. So that would satisfy, what we're essentially saying is, what are all the combinations if we were to get into each of these different possibilities by ranges. And PX, so let's go to PX, let's follow this thought. We would then do the same thing here. Anything under 2006 for A would go with S being less than 1351. would go to Q, and then the same thing for anything M over. Anything under 2006 would go here. Anything over 2006 would go into the next rule of 2090. Anything over 2090 would be accepted, and anything under would go to RFG. So we would resolve every single rule in every workflow. And anytime we get to an accepted value, we would have to know the ranges of, so it would be 1 through X for this, 1 through, so that it's not just a summative of, but it's between my range, we're adding our numbers. And so what that means is we don't have to computationally determine all 4,000 possibilities, 4,000 times 4, whatever those are, which really goes beyond that. Distinct combination of ratings will be accepted, because it's multiplicative, right? So if it's really 4,000 times 4,000 times 4,000 times 4,000. So I think this is your total possible combination set. Hundreds, thousands, millions, billions, trillions, 256,000 possible, 256 trillion possible, 256 trillion, 256 trillion, or just 256 trillion. We should probably edit that out of the video. It was just a dumb comment. It's late. 256 trillion combinations, which is a ton. And there's still 88 trillion possible combinations that weren't processed in this particular example. But we don't have to calculate all those, because we just have to calculate them and then we just multiply. So let's talk about how we're going to do that. So I mentioned real quick in the example that we're going to follow, and we need to satisfy each branch of each workflow. So for instance, because this has one branch where S is less than this value, we're going to pass everything. We're going to pass one branch underneath with S less than 13,521. And we're going to pass everything that's with S from 1351 to 4,000. X would be 1 to 4,000. M would be 1 to 4,000. A would be 1 to 4,000. Would all go to QQZ. And then PX, we just follow that same pattern. And when we send one range here, the other range can move on to here. But then this then augments the final range. So I think I understand what we have to do. So we can essentially do what we did already, but it becomes a range for our rule, in that we only have one entry rule with a range of 1 to 4,000. Because the part assessment, we're going to have to change some things. Not a lot, but enough where I think it makes sense. So all of the workflow rule stuff pretty much stays the same. Do I make this more recursive? Because in this case, we've established the initial workflow of in for this particular part. Or do I base it off of a queue of some sort? I could create a queue and I just add the next workflow to the queue. Let's consider this seriously, as I don't see any reason, given a branch, that we couldn't follow it all the way to the end before we go and we call the next one. This method here, though, won't work. So I can, instead of doing a for loop here, I could just recursively call a function that passed in the new workflow and the part, and return the accepted parts, right? So that in each diversion, only the ones that are accepted get returned, and then we append them we just append them as we go up. So let's look at that. Let's break this apart. And I think because that's really the challenge, is not so much this, but my approach here with just iterating in a for loop isn't going to work. I don't typically like labels anyway, and so I think that was probably my sign of probably should think about this a little bit differently. Let's start here with our initial set of parts is going to be just, well, first, our parts are going to change because it's going to be a map of, because we really only have one like part rating, so to speak, and we can do a slice of ints. Maybe we can do rating min max, but we're just going to do 0 index as min, the one index as max. And so, but we already know what the initial sets are going to be. So it's going to be X, which will be 1 to 4,000. M A S. Okay, so that'll be your initial like part. And then we don't really have this, we'll have to change this because this will be a set of sets of, and that's fine. We can do that. I'm sorry, a set of map of string. This needs to go on the other side. Slice of int. Okay, so that way our accepted is going to change as we diverge. All right, that's good. And then this will have to be yeah, okay, sorry. Because the X, M, A, and S, those ranges are going to differ. We're going to need a slice. We don't really have an initial for loop here because we just have a part. So we're going to break that first. Now, is match. We're not going to use is match. It's got to get a little bit more complicated than that. We'll call it is match 2. Because we can still use it. Let me try this. Split workflow. Let me think about it for like this for a second. So if we've got a part, which is a map of string to slice of int, and we've got a workflow, which is a workflow. P, which is part, workflow, which is workflow. And what we want to do is, so it will be similar to this in the sense that we'll need to look at each rule and yeah. So if it's an A, we're going to append. And we're going to append new P, potentially. Okay. So we're not breaking, though, because we're going to process all the rules. And there's still a continue that will happen here, and there's still a continue that will happen here. This is going to be okay. So we also need the workflows. Okay, so split workflow. And we're going to pass in the part. We're going to pass in W, and we're going to pass in our workflows, right? What am I doing wrong here? Yeah, you're going to return this. Except not that. And we return yep, and then yep, and then workflows is a map of string to workflows. So I think this is fine. Okay. Yeah. Okay. So now the question becomes how I split. So we've passed in a starting value, and as it matches, we have to adjust and pass. Maybe this goes away and maybe we do something like, so first we need to figure out, does the P passed in, P, does it have enough to satisfy this first rule? So only if the rule dot identifier is not equal to, do we need to come in here and do some additional validation. So then we'll say if rule dot operator equal to greater than. So if we're saying the value has to be greater than 5,000 or whatever the value is, then we're going to ask the question, if rule dot value if P sub rule dot identifier sub 0 greater than rule dot value, then so that's the min, so there's nothing more to do. So then we can return, no, not return, yes, return, because we're looking, it would have to, we're passing to it what it could satisfy, but if we can't satisfy the first condition, no, continue, because we may have something that would be lower than a value, but the next value could satisfy. And we know that even if we don't satisfy any values, we will eventually end in the default condition for that workflow. So if we have a greater than and our minimum value is, if we're saying that it has to be greater than the value, and if our max value is less than the rule value, we continue. sorry, let's think about this again. Let me go back to this. If all of it, so if our min value is greater than our value, then we're gonna split our workflow. We're gonna return split workflow with P, whatever P is available. Because at this point, everything we have encompasses that rule, right? Everything that's left encompasses that rule. So we're going to take it and we're going to just return it, and it's going to be accepted equals accepted. What's the issue? Yeah. Okay. So if all of it fits into the bucket, then we return it. If some of it fits in the bucket, then I think I'm going to take a break and come back to this. But the answer is that we need to call split workflow, but P equals to copy P. The problem is that need a copy of P with P sub rule dot identifier, because P the original P needs to move on to the next value. All right, we're back in the saddle. Just tackling day 19. I was just exhausted, so I stopped here. We're going to keep moving forward. So we've got a couple of conditions. So if our operator is this way, we're going to go this route, which is to say that if everything is satisfied by this operator, we are going to return that. Otherwise, a portion of it may be satisfied. We need to check to make sure that at least the upper bound is satisfied. And if the upper bound is satisfied, then we are going to do two things. I definitely think we need a copy of P, because just my knowledge of Go, this is really just a reference to the map. And if we manipulate it, it's going to manipulate the base P, which I really don't want to do here. I want to say, hey, take this work and kind of split from here and do your thing. I think, I mean, does it make sense actually that the rule moving forward is just manipulated? Because really it just matters what's accepted at the end, right? So if we have a rule which is all encompassing, we pass that, and that's our return from this split of workflow, is to split workflow again and passing down that object. The alternative is a portion of it matches, and we want a new P that is that new portion with everything else copied to move forward. But P gets manipulated, and P is what is in the next loop of this iteration. it makes sense because that means our primary object is always going to move forward with the remainder to the defaults. And on the last pass, because yeah, if P, then it's just P, right? And then this is also just P. So if we're finally accepted, we append P. Otherwise, right? So then workflows. Okay, I think this makes sense. So if we hit an accepted state, we're kind of done. There's if it's just purely accepted. So if we don't have an identifier, if we have an identifier, we follow those rules. I think doing it this recursive way, since we're always going to kind of fork to the destination, I feel like the easy thing to do is add accepted and rejected into the workflows. And that way we can just pass it in, and then all we do here in this recursive split workflow is return. So we can actually, my idea here is that we remove this, or we move this, and we move it. Yeah, so we can move this up here, and then we can say if workflow dot name is this. All right, so this is what we're doing here. If we get a workflow with the name of R, which I know doesn't technically exist in our list, or we get a workflow with the name of A, we're going to take these two actions. So what this will do is it'll allow us that whatever workflow we're acknowledging here, we're going to just keep flowing in it, right? Even if the default is A, we'll still call this, and then we're going to return that particular rule set at that point. But this will allow us to just flow in that direction. So accepted, right? So we know we have a split here with the rules. We need to build our new P. I think this is the only new P that we need. And so our P is this. It's the map of string to int, and right. So let's just create a function called new part from part, really, or copy part. We'll call it copy part. I think in this case, it kind of makes sense to actually do this on the part. So I'm going to do it on the part. This one makes sense to me. So we have this structure called part, right? Or did we not do that? Oh no, I take it back. Okay, so disregard. Right. So we'll just do a copy part. I was thinking about putting it on the struct, but I realized we didn't create a struct for the parts. So we have a part, which is this. We went with a map, and honestly, it's more work, but I would not have done that. We probably would have went with a more proper struct. It's just easier this way to represent it. So, and then our exit is going to be this. And so our new is going to be this. And then our for key value in range of parts. The reason we're doing this is because we don't want to manipulate, we are going to manipulate the current part, but we don't want to manipulate the current part that we're passing down. So we're going to start here, and we're going to say that n sub k equal sub v. So now we've got a perfect copy of the initial part. And so we can do new p is copy part. right? I guess we just called it P here. Awesome. So new P is going to get passed to this split workflow. And then we've got to do two things. Okay. We've got to manipulate current P, and we've got to set new P. So since we know we've got a value that is higher, right? And we know that our rule value is going to be less than, we're going to set new P equal to P sub rule dot identifier sub 0 equal to our rule dot value plus 1. So that's our new P. And our old P because that's the min, right? That's our min. That's the correct way to do it. And then P, which is going to continue on to the next iteration, the identifier max will be rule.value. And so that will give us the split of it's going less, and it's the new P is going to start a new life with just that particular identifier passed, and the old P is going to or the current P is going to be manipulated to go to the next rule. So I think that makes sense to me. I don't want to forget about this, so I'm going to just create on part 2, when we create our workflows, workflow sub A, we're just going to create a workflow with the name of A, and the same thing with rejected. And so this will just, those workflows aren't actually going to execute, but they're going to exist as in just an instruction set that simplifies our code just a little bit. We're going to define them. They don't have any real purpose other than that we can call workflow and then make our decision on whether we're going to, it's an additional call, a split workflow, but it says, hey, we've either don't want to return anything from this route, we're not going to do anything further, or B, we've got an accepted route here. So that's good. Copy of P is done there. And then we're going to look at one other condition. So we've got a secondary operator. And actually, we're going to, just because we're going to continue, if we meet this condition, we're going to continue because we can go to the next rule with P. We don't have to evaluate this next step. And then this next step is really going to be less than, right? So we can get rid of that and that for some complexity. We don't need to reduce complexity a little bit. And so if our max, which is the right side, is less than the rule value, then we know the entire thing is going down that route, and we can just return that. The other bit is if the min is less than that value, then we know we have some things in our range that need to satisfy the new P. So the new P is anything less than, so it is going to be, the new P is going to be, the new max of P will be the rule.value and the new P, and the other side will be inclusive to, so it'll be the minimum, sorry, this will be -1. We know that our new P, since it satisfies, has to be less than rule.value. So it's going to be rule.value -1. And the current P, the minimum is going to be rule.value. The max is going to be whatever the max is. That should all be fine. So now, Similarly, new P is going to live on a life of its own, and P is going to come back up here to be iterated on. So there's always going to be a primary path of P, but there will be an opportunity for P to fork off. None of this is going to be needed anymore here. And so if rule.identifier not equal to that, yeah, because if we have a rejected or accepted as the last condition, then we'll just call that workflow. So, and then that workflow will dictate what the next step is. And then we just have special conditions for those workflows. I guess really we could build these workflows as a method that kind of encapsulates these rules and then calls the next workflow and then the default execution. Anyway, I'm getting off base here. So now how do we score, right? We've got all these accepted. How do we score? The scoring is going to be different for part 2. We'll go ahead and create a score. And that's just going to receive in this accepted list, which is a slice of map of int, which is the points. And we'll call this accepted. I guess I could just accumulate the score like as we resolve each one, but this will kind of give us if we do something in the future. I want to do something with visualizing what these admin codes look like, but that might come in a future video. I'm not sure. So maybe it's useful, maybe it's not. We may run into some memory issues, but let's just see what happens. So our score is 0. And then we'll say for parts in range of accepted. So we've got a part and we've got these min max values for the part. In order to score that, it's a multiplication of what's in the max min, right? So so I guess we could take the key, right? Well, no, we don't need that. Sorry. So then it's so range of part. And then I think that's what I called it above. It's going to be, so the part rating. So if you want to find how many possible options of Xmas, so X, it'll be X times M times A times S, but it's going to have to be per part. And so we'll call it combinations equals 0. And it's going to be rating combinations times equal multiplied by rating sub max minus rating sub 0. So the max minus the min. So if we've got a max of 100 and a min of 50, that'll be 50. And combinations needs to start at 1 because multiplying by 0 gives you 0. And then once all the combinations are calculated, we plus equal that to our score, and then we return score. So that I think should do it. Let's see. I've got it now. Be interesting to see. Okay. So let's fix this. And then let's create the test. And the result is this, man, it's super high. Okay. So now seven. Just 7. That's it. Just 7. That's awesome. All right, well, let's see if that's an issue with my scoring or what. So, at least it finished fast, right? Let's print out the accepted set. Let's give some more screen real estate. Why did I have a bad habit of doing that? Right. So, okay, so the accepted definitely doesn't look right to me. So that means we have an issue. All right, so let's look at greater than. So if 1 is greater than the value, these all sort of just feel like copies. Let me get this printed a little bit nicer. There's a package I use from time to time called Spew in Go that's really good for printing some of this stuff out. But I think I'm just gonna do 4. We'll print the part. That way we get a line for each. And then let's just do 4 range apart. We'll do and then we'll do let's try that. Yeah. Oh, way better, way more readable. Okay, 14, 16, 14, 16, 14, 16. This is just a copy of the same part, I think. In fact, we could probably, if we wanted to, think, is that going to do what I'm looking for? No. Although, I want to check the actual, like, reference. Is this going to work for me or no? No. There's a way. Let me see if I can find it. Golang get pointer ref ID, I think is what it's called. %P? Ooh. Never used that before. I think I can undo this then. Oh, interesting. Okay, so these are different numbers, but they all ended up in the same relative. That's duplicated. That's duplicated. Interesting. Okay. So we got to figure that out. So I think if we don't have an identifier, that means everything is going. So we just need to return that as a whole. So then that gives me better, I think, because we've got, this is still wrong, but this is in the right direction. So we've got some branches now. Okay, let's look at what we're doing here. So P should never be greater than if the max is greater than the value. That means the max becomes the value. And the new P's min, hold on. Now these should be transposed. If the rules So if the max is less than the value, the entire thing goes. And we're returned. I think this is also a problem. We need to continue here because at this point we have an identifier. Yeah, so we need to continue here because at this point we have an identifier. We need to go to the next rule. Only if we don't have an identifier, which is the end state, do we do this. Which I suppose we can move this rule up and that might make it clearer. Is that, okay, we still got a problem, but let's move this rule up. This will help because it will allow us to unembed this, and we'll say instead, if we don't have an identifier, then we don't need to do any additional checks. Okay, still only 3. So there's a problem with the way our rules are being defined here, and that's okay. I mean, it's not okay, but it's interesting that it only splits 3 times. That seems way less than I was anticipating. The values that are being assigned, though, is not correct. So, right, back to this. So, if our max is greater than our value, then we know we're going to segment. So our current P will have to be up to our value for our max. Is this the problem? Is this being copied? And that's... Okay, so that was being copied as well. All right, so that's solved part of my problem. And these are definitely different references now. So there should not be any overlap. We're close. I feel like we might be dealing with an off by 1 now. We're too low. So let's look at this. Should we be starting at 0 instead of 1? Is that the issue here? Did I do this for part 1 as well? No. So I think that is the right move because it's 0 to 4,000, right? Let me check. Can have an integer value ranging from a minimum of 1 to a maximum of 4,000 of all possible distinct combinations of ratings. Your job is to figure out which one will be accepted. So let's look at this again. If our minimum is less than 0, we copy it, the new P sub 1 equal to the rule value, so whatever that minimum is, minus 1. So we know we've got from wherever we are to wherever we can go. And then P itself becomes whatever we have, which is the max value. And the min value becomes that value itself because the rule is less than. And the same thing with greater than. It doesn't include the value, so we have to plus 1 it on the min side. And on the 1 side, we include that value as the max. And we move on to the next operator. Yeah, I think I'm going to need to just walk through our test example. This is going to be a little painful, but gotta do it. So let's just create a new file. And this is going to be 0 to 4,000, 0 to 4,000. We're going to do 0 to because we want to include right. So this goes into PX. And what do we want out of our first iteration? So we've got A is less than 2,000. So our first split becomes this. We've got right? And then we've got all possible distinct combinations of readings. At least distinct. How did we ever get here? So I messed up already. We got to start at in, right? So in gives us, at the first layer, it gives us S is less than 1351. So S becomes, we'll do P and P. So P becomes, so S is greater than 27.7. I'm sorry, S is less than 1351. So then P becomes 1351 to 4000, and NP becomes 0 to 1350, right? And so NP goes to PX, and then P moves on to QQZ. So do I have that? We won't know what the end state is until I follow it completely. So then PX, let's go to PX. So PX is going to be A is less than 2006. So A becomes, NP, which is the main thread, will be 2006. But off of this, this is going to go to QKQ. The next one is going to be, this is 0, 2006, is going to be QKQ because it has to be less than, and then greater than 2006 to 4000, which goes on to M is 292 is greater than 2092, so this becomes 2092, and that goes to A, which is accepted. And then we've got NP, which is, this was inverse, 2091 to 4000, 2091 to 4000, and 2090. Okay, so, and then this is accepted, and then this goes to RFG, right? I think that is the path. So we've got one accepted, so we should have a 0 to 4000. Let me put the, I just realized, let me put the key in my print. Right, okay. So back to our output. We have something that finishes with X 0 to 4000, and then M should be 2091 to 4000. Is this it? 2091 to 4000, 2006 to 4000, 0 to 1350. Okay, that seems right. Okay, let's look and see. So RFG. Let's follow QQZ. So I feel like we're on the right path. Let me just change one thing here. Let me switch this out because I'm not sure if this is going to make a difference. Let's do it this way. So I think what was happening is we were losing the 4000th value. And even though I started at 0 instead of 1, I think because of the way math works, we were missing it. We were missing one of them. I think it was the 4000th value. So by doing the difference and then adding 1, you want to include that. And so now we've got a pass. Okay. So as you can see, calculate those, it's not that many, and that was pretty quick. So let's do one last thing. We're going to bring in part 2, and I'm going to close this. And wow, that's very fast. So let's take a look here. Somewhere around, 608 possible iterations. I kind of like that I kept these in a map because I could always come back and, reference the final part paths. But let's see if that works. There we go. Awesome. Solved it. Little struggle there with the maths, but we got it knocked out. So let's go back and review the initial problem in the solutions. So we have this set of values, this input, and the input is a set of workflows keyed by the first set of values and an instruction set. And depending on that instruction set, you would then send it to the next workflow. If you hit an A or an R, your path is done. And so in the first set, there's a second section, which is your inputs, which is basically your part ratings. And so the goal was to loop through all of these and figure out what the value was of those that were accepted versus rejected. And so we built a little workflow processor for that. The way we handle that in code with part 1 is we split based on the inputs double hard returns here. And the top section is our workflows. The bottom section is our ratings or parts with ratings. And so I created 2 functions, parse workflows. And then so the next step was parsing. So we parsed the workflows. Then similarly, we parsed the parts. And we ended up with a set of parts and workflows. And then our first part was pretty easy. We just iterated through them forward. And anytime we found a match, we broke out if it was either rejected or accepted. Otherwise, we reassigned workflow and moved forward. And we did that on each part in their sets of ratings, eventually finding the ends and then figuring out what the score was for what parts were accepted and rejected. The second part was still pretty straightforward, but we had to do a little bit more. So in the part 2, the idea was that we will need to see how many possible permutations. So we put that in place. I added workflow A and R so that we can simplify our code. And then this is just for debugging. And then what I did was you get all the possible accepteds and then you run the combinations based on the ranges of a high and low value. But that's all I have for now. So as always, over and